reading and communicating information. Our names are Megan, Melissa, Lisa, and Sarah. Practice 8 says, any education in science and engineering needs to develop students' ability to read and produce domain-specific text. As such, every science or engineering lesson is in part a language lesson, particularly reading and producing the genres of text that are intrinsic to science and engineering. So what does that mean? The major ideas of Practice 8 are as follows. Practice 8 is overlapped by each of the previous 7 practices. We're building off prior knowledge and observations. The main goal in the practice is for students to read, interpret, and produce scientific and technical text. They need to be capable of reading and understanding scientific text and also have the ability to communicate scientific methods and ideas clearly and persuasively. If you want more information on Practice 8, there's a video below that you can check out.
Okay, and so if you're looking at Practice 8 being applied throughout the grades, through kindergarten and second grade, you can see students read and comprehend grade appropriate texts. They can communicate and design ideas and solutions in oral or written form. They explain how images clarify text and record observations and thoughts. In grades 3 through 5, they compare and combine scientific texts to acquire information, use various forms of media to communicate. An example would be tables or diagrams or charts, and they also use models to share findings in oral or written presentations. And then 6 through 8, we don't really worry about 7 or 8, but for us, grade 6, we would see them as evaluating merit and validity of ideas and methods.
Okay, since most of the text used in science and engineering is primary literature, a lot of the times students have a hard time understanding the language used and have a difficult time understanding. So it is important to adapt the primary literature into narratives so the students are able to better understand the lesson. It is also important for students to be explicitly taught how to interpret the scientific texts and how to interpret the graphs and charts they are seeing. Some examples of the graphs and charts are the butterfly cycle and the animal classifications.
Once the information is interpreted, it is important for students to understand how to communicate that information. So being able to communicate what they've learned through scientific texts, lectures or papers or the internet is crucial to being able to advance in science. Children should be able to communicate the scientific ideas that they learned and their results of their analysis effectively. There are informal and formal ways, informal discussions, social media, emails, presentations, and formal would be books and journals or writings. Here are some examples of formal communication. So a science notebook, kind of like what we have in class, allows students to communicate findings, data, and thoughts and share what they've learned through the lessons. And presentations allow students to share what they've discovered with their classmates. And some more examples are mini posters or foldables, another way to share ideas with classmates and other students to communicate their understanding of the subject. We hope you enjoyed our presentation. That's it for now. See you later.